Hi class, let's continue working on this table 3 here. Table 3 is using other ways to calculate the changes in cash. So the first approach is to get the mean of cash from the portfolios, based on MV and based on Tobin's Q here. So, and the difference between the actual number and the average in the portfolio, benchmark portfolio, will be the DC1 here. This is another measure for the delta of cash here. So I run the regression and using DC1 here, and the results of the regression is stored at this variable. And the second approach for the DC is to run regressions, and this is in the paper is equation 10, and it's in the PowerPoint. So you see, to get the delta of cash, change of cash, to run the regression on cash flow and also on Tobin's Q and firm sites to get the changes in cash. And another way to do that, so based on this, we got DC2, and based on this equation, we got DC3, adding more variables to this equation. And the results is stored in M32 for DC2, and the next one is DC3. The result is stored here, and then so we can save the result in table 3 in Excel. Okay, so I run the code. So here's the results. So you see, for DC1 and DC2 and DC3, the results are similar. This is DC1, this is the coefficient. This is DC2. This is DC3. Okay, so this is table 3 as a robustness test for table 2. Now, table 4 is testing the third hypothesis. The third hypothesis is this: an extra dollar of cash holding is more valuable to shareholders in financially constrained firms. So as compared with financially unconstrained firms. So an extra dollar are more valuable if a company are financially constrained. So to measure the financial constraint, this paper uses several approaches. One way to do that is to use this payout ratio to separate constrained and unconstrained. And another one is use firm sites to separate the two. And also the third one is using bond rating to separate the two, and commercial paper rating to separate the two. 4 approaches. Let's take a look of the code here. So first we need to separate the firms based on financial constraints. So it's using a log of sales and divide all firms into 3 groups. So the top 33% and the bottom 33% and the middle one. Okay, so also create the dummy variable G size equals to 1. This is financial constrained firms. And unconstrained, that's in financial constrained firms. And this is a dummy variable, and its group based on this is the first group. It's financial constrained firms. And if it's in the third group, based on this quantile, this function, so it's non-constrained firms. And for the others will be called other sides. So it will be the rest of the firms will fall into this group. And let's run this. So here it is. So if it's 1, so it's financially constrained. So it's in the top it's in the top 33%. And then so financially constrained is the from the it's from 67% to 100%. This is NFC firms, and the rest will be others. Yeah, from 0% to 33%, and that will be the financially constrained based on size. And then if it's above 66.67%, so it will be the financially unconstrained firms. Okay, and then after that, we have firms classified into the groups, and then we need to compare. We need to compare the two groups for its DC, LC, all these variables. So we want to know, like for financially constrained firms, its DC is higher or lower. It should be higher. We're expecting to get higher DC for financially constrained firms than unconstrained firms, because they need money, and for any additional money and additional cash, and it's more valuable to financially constrained firms. And then so we're using matrix here. So first we should use this word count to see how many variables. So we have 8 variables. So so we want to create and use 8. So this is 8 times 2. So we have 16 here. NV equals to 16. And then so we create, in this case, we create a 16 by 2 matrix. And then so and then we calculate statistic. We report the statistic values for each variable here for both financially constrained and unconstrained firms. And then so the result will be stored and then so if we check AA sites here, so it should show the results, and let's take a look. So it will just compare these variables between the constrained and unconstrained firms. Let's see how it does. Okay, so it seems like difference for financially, C stands for constrained, U stands for unconstrained firms. So there are significant differences for these variables. Okay. And the details how to do this is in table 3 of another paper, not this paper. Okay, so this is using the loop to calculate it, so we don't have to run each variable. But you can also, if you don't use this loop, don't use the matrix, so you need to just work on each variable one by one. Okay, so the next one is, since the previous one is based on sites, based on sites to separate financial constraint from unconstrained. So next one is using number of dividend. The company pays how many dividend in a year to tell it's financially constrained or not. So if the company pays more frequently, then it's not financially constrained. Rarely did the company pay the dividend, so it should be a financially constrained firms. So this is the idea why it's done this way. So find out how many times the company paid dividend in a year. And if it's less than 2, so it's financially constrained. If it's greater than 8, then not constrained. And for others, and it's in between. And then also do the same thing like previously, and run the regression, but replace the group by the newer one. And then let's see the difference again between these two groups for the major variables. It seems like it's still different, but the differences are not so dramatic like previously for this one. Also, the next one is the amount of dividend paid, and to use it to separate financial constraint from unconstrained. So if its dividend is greater, the company pays cash dividend, so it's not constrained. Company doesn't pay dividend, so it's financially constrained. And so to group the firms this way, and again run the regression with the new group. So the results are similar to the previous one. Okay, so this is the, and we put them together, so it will be the table 4. This is the code to do that, and should be saved in table 4. Table 4 is this one. It just shows like if we're using the payout ratio, firm size is the first one we did. Based on the firm size, the differences is how much. So it's comparable with table 4 here. Now this is table 4. Okay, so we will work on table 5 in the next video. Thanks for watching.